Welcome to another video, calculating volume for Polyhedra. As a lot of things in this course, I know that you know how to find volume, especially of a rectangular prism, but we're trying to push you to understand it more deeply. If you haven't played with my friend Ted's app in GeoGebra from the previous video, really encourage you to do that and thinking about why is the volume of a rectangular prism length times width times height, and really thinking about the cubes and the number of cubes and the layers of cubes. That's all really helpful and important in understanding volume. If you have some cubes at home, I would encourage you to use them for this activity. If not, you'll have to kind of imagine or kind of think about using Ted's GeoGebra app. So this activity says to build a 3-inch tall prism that has this base here. So we've got this base. This is the base of the prism, and it's saying to make it 3 layers tall. Can you picture that? So each of these squares is a 1-inch by 1-inch square. So if I was to build on top of this, and I'm afraid this is going to be a very poor drawing, but from the front side here, you would actually end up just looking like a square, 3 inches by 3 inches. But then on the top, you're going to see the T shape here. Can you picture this? Again, I apologize for the poor drawing. Need a bigger eraser. Hopefully you can picture what that's saying. So taking this shape as the base, you can see the top base here. You can imagine the bottom base would be similar down here. So how many layers does a 3-inch tall prism have if these are 3-inch cubes? Well, there's 3 layers, right? 1-inch cube, 2-inch cube, 3-inch cube. So this would be a total of 3 inches tall. How many cubes are there in each layer? Well, you could picture 1, 2, 3, 4 cubes in this layer. You can picture there would have to be 4 in each layer. So what's an expression for the total number of cubes? Expression means you just don't calculate it. It's 3 times 4. Now, this is really interesting. So the formula that works for boxes or rectangular prisms, volume equals length times width times height, isn't going to work so well for this, right? Because my length, is it really 3? Or is it 1? And my width, what's my width? Is it 1? Is it 2? But you can see here, there's something we can learn here, that there's 4 layers, that's the area of the base, times the height. So for any prism, the volume is going to be the area of the base times the height. And this works great because then I don't have to memorize a bunch of formulas. I just have to memorize one. So these got stretched out on me, but if you look, how do I find the volume of a triangular prism? Well, I need to find the area of this triangle times the height. Now you have to be careful. It's the height of the prism. Maybe I need to correct that here. Times the height of the prism. Because we really have two heights, right? We have height of the triangle. And then, do you see this is the height of the prism here? And this is going to work for any of these. I could take this area times this height, and so on. These shapes, it's going to be a little more complicated, but it's the same idea. Find the area of the hexagonal prism. You might be thinking you have no idea how to find the area, but what if I broke it into triangles for you? You could find the area of those triangles, couldn't you? And so on. That tells us for any prism, we are going to find the volume by taking the area of the base times the height of the prism. And that is all for this video. So, quick review. To find a volume of polyhedra, we just need to find the area of the base and then take it times the height. And it works for all of these. You may be wondering